Okay, well, the first thing I always like to say is this is a proper flight deck. None of this poncy glass cockpit rubbish. These are proper instruments, needles and dials. So what we've got here, first of all, the flight instruments. You've got a suite of flight instruments for the captain, the left-hand seat being the captain's seat, and those instruments are all reproduced for the co-pilot on the right-hand seat. And I don't know whether you can see them clearly or not, but the instruments are airspeed indicator. That's a standby. That's the airspeed indicator there. Artificial horizon, rate of climb and descent indicator. That's a radio altimeter, pressure altimeter, and another altimeter here. A compass here, and a compass here, and a Mach meter there, and that shows the angle of incidence, that instrument there. And those instruments are all reproduced on the right hand side. In the middle you've got engine instruments for the 4 engines, N2s, N1s, fuel flows, EGTs, and the area of the nozzle at the back end of the engine. Coming across here, you've got all this stuff associated with the autopilots. Autopilot switches are there, auto throttle switches are there, flight director switches, and you can set the whole thing up for coupling up with the inertial navigation systems to the autopilot. You do that all through the switchery up here, and you also couple it up for automatic landings, automatic approaches and landings if you're landing in foggy weather at Heathrow. So that's for all the autopilot stuff. And then coming up here you've got a master warning system, and then coming up here a whole series of instruments, really switches related to various sort of technical issues to do with hydraulics and engines. I'm not going to go into all that lot there. And you can't actually see the flight engineers panel, but maybe we'll get a picture of that later on. But it's without doubt the most complicated flight engineers panel of any civil airliner. And one of the reasons the flight engineer was such an important person on the Concorde flight crew was because when you go supersonic with Concorde, you create a shock wave, and that shock wave forms on the nose as a sort of wall on the nose, and as you go from Mach 1 to Mach 2, that shock wave gets deflected backwards, and finally when you're flying at Mach 2, that shock wave is like a cone radiating from the nose, trailing along behind the aircraft, down to the surface of the earth, out sideways and up to the upper levels of the Earth's atmosphere. And that shock wave trails along like that behind the airplane for the whole time that you're flying supersonic. Now, as that shock wave changes shape from the sort of wall, if you like, and then it gets deflected backwards, what it's doing by changing its shape like that, it's pushing the center of lift back down the wing. And if you didn't do anything about it, you'd end up with the center of gravity where it was, the center of lift having been pushed way, way back here, and you'd end up with a horribly unbalanced aircraft wanting to pitch nose down all the time, which you could correct for aerodynamically if you wanted to, but that would incur sort of drag penalties, which are highly undesirable. So the solution to it, and this is just one of the examples of what a brilliant team, and I can't emphasize this enough, the team of aerodynamicists and engineers who created this wonderful, wonderful aeroplane were a brilliant team of people. They really were. And the solution they came up for that particular problem was, hey, if the center of lift moves back down the wing, let's move the center of gravity back with it. And then when it goes subsonic and the reverse process happens as the center of lift moves back forwards again, we can pump that fuel back forwards again. And that's exactly what we used to do. And that was the flight engineer's job, was to change the position of the center of gravity. And just to illustrate the amount of the change, by comparison with the position of center of gravity at takeoff, by the time you were flying at Mach 2 and you'd push the center of gravity back by pumping fuel into tank 11 in the tail cone, the center of gravity was about 8 or 9 feet aft of the position it was in for takeoff. So it was a substantial movement. And it was something that needed to be monitored, obviously, very, very carefully. Very important aspect of the whole thing. Another thing, while I'm on the subject of these brilliant engineers and aerodynamicists, because you're going so fast, the airframe is being subjected to frictional heating and to heating caused by compression. And the temperature on the skin, on the nose, goes up when you're flying at Mach 2 to a maximum of 127 degrees. That was the limiting temperature, 127 degrees Celsius. That's about 260 degrees Fahrenheit. And I could pull back this trim up above my head here and actually touch the bare metal of the aeroplane. And I tell you what, you didn't keep your finger there any length of time at all. It was red hot. And the airplane actually expanded by about 9 inches, they tell me. So you've got this airframe expanding as you go supersonic and then contracting again as you go subsonic. You can't have that process affecting the passenger cabin. I mean, the passengers would be most disconcerted if they saw the cabin floor sort of stretching and the carpet ripping itself apart. So the whole cabin floor sits on a system of rollers, if you like, so that the fuselage can expand and contract and leave the cabin floor completely unaffected by the whole process. I mean, they were just a brilliant team of people. Like, they were geniuses, some of them. They really, truly were. The brain power that went into this is staggering. No other word for it.
So, John, could you show us the throttles and where the reheats were?
Yep. The throttles are here, and I'm unable to move them forward for some reason. They're locked, and I can't unlock them, I don't think. No. Anyway, they're the throttles, and the reverse thrust, the little handles there, and once you landed, the throttles are fully closed and you pull back on those reverse thrust levers, and that helps you decelerate on the runway. And then the reheats in the actual airplane that I flew, we're sitting on a prototype Concorde here, and it's a bit different. The instruments are not entirely exactly the same as they were on the airplanes that I used to fly. I've never flown this one at all. The reheat switches in the production airplanes that British Airways flew had piano keys for reheat switches. On this airplane, you can see they're just switches, just toggle switches. On the real airplanes that I flew, they were nice white piano keys, 4 of them in line there, and there's a gang bar that you could select them all 4 up at the same time, and a gang bar to select all 4 off at the same time. So when you got to the pre-takeoff checks, one of the items would be to select the reheats, pre-select the reheats on. They wouldn't come on because the throttles are at idle at the moment, and then once you started the takeoff run, as you opened the throttles up, those reheats would automatically cut in, and off you go, blasting into the air. And at whatever the noise abatement time was, something like 1 minute and 15 seconds after starting the takeoff would be a typical sort of noise abatement time. The non-handling pilot would go 3, 2, 1 noise, and the flight engineer would then cancel those reheats and throttle the engines back to a predetermined setting on the throttle quadrant. And that would obviously cut the noise level, and we'd tiptoe past Windsor Castle so as not to disturb Her Majesty, and then sort of gradually reintroduce full dry power, unreheated power, for our climb up to the subsonic cruise altitude.
There was also another unique feature, was the nose cone actually moves up and down, doesn't it?
Yep, the nose cone does move up and down, and there's the control. And basically 4 positions for it. The one that it's in at the moment, with the nose fully up and the visor, the heat shield, you might be able to see it on the picture. What you've got here is a conventional windshield, like any other aeroplane, and then beyond there, encased in those heavy-duty black bars that you may be able to see, is the visor, the heat shield. So here we are with the nose up and the heat shield in its streamlined position to give the airplane a nice aerodynamic shape. The first stage of lowering things is to put that lever down to that detent there, and that brings the visor down into the nose cone. The next stage is to lower the nose to 5 degrees, which is that one there, so that then the whole nose cone goes from fully up to 5 degrees down, with the visor stowed inside the nose cone. And that's the position that we used to use for taxiing, for takeoff, and for flying around in the immediate airport area. And then the final position is fully down, nose 12 degrees down, and that was the 12.5 degrees down actually, and that was the position we used for landing, and that was part of the landing checks. So after you'd selected the undercarriage down, the next item was nose to 12, nose fully down. And the only reason for lowering the nose was to get that great long nose cone out of the pilot's line of sight, because you're coming into land at about 11.5, 11.75 degrees nose up attitude, and if you didn't get that nose cone out of the way, all you'd see, no sign of a runway, just a nose cone, which is not very satisfactory. We were trained during the training, incidentally, to land with the nose stuck in the up position. As far as I know, it never ever happened. It certainly didn't in British Airways. I don't think it ever did in Air France either. And in fact, there was a very effective emergency drill for lowering the emergency lowering of the nose, which was simply to depressurize the hydraulics and let Mr. Newton's laws of gravity do the business. So the nose sort of dropped down, clunk, into a nose down position. So there we are. That's the reason for the nose cone, and the fact that it moves around is just simply to give the pilots a decent view of the runway when they're coming into land.